This is a short video that aims to show how structuring elements can be applied to grayscale images in the morphological operations of opening and closing to remove noise. Of course, you can use opening and closing to try and get more defined regions in binary images that you can then perform region detection on to do computer vision, simple computer vision stuff, such as counting the number of coins on an image. But in general, the best way to go about this is to first threshold the image so that you're only working with two colors. For grayscale images, there's more interest in simply eliminating noise. So since this is supposed to be a video about grayscale images, that's what we'll focus on. We're not going to threshold them. So I've devised a simple function here that will take a stock image, which is a small picture of Saturn. The smallness of the image does matter here. In general, larger images respond better to the application of a structuring element, and we'll see just why. And we're going to show the original image on the screen. We'll show what it looks like with some noise added. We can use different kinds of noise. We'll see what it looks like when we open it, and we'll see what it looks like when we close it. Okay. So let's try some stuff. So the opening function, which I created, takes the noise type and a structuring element. The ones function can be quite helpful here. So let's start with a structuring element that's a 2 by 2 array of ones. So it'll have a 2 by 2 neighborhood. Okay. So what I see here is the original image, some Gaussian, some normally distributed noise added, and then it looks like the opening, or the opened version of this image has done a better job than the closed version, which is interesting. And it makes sense because we have a black background, and the opening is erosion first, right? So this white will tend to go away, and then it'll stay gone. Whereas with closed, the white gets bigger because we dilate first. So that does make sense. We would expect that since it's mostly white noise on a black background, that the opened image would look better than the closed one. This is a 2 by 2 structuring element. It looks pretty decent. We've lost some detail. If it were a much larger picture, there would be less visible elimination of fine detail, but this is the image we're working with right now. So let's try making the structuring element larger somewhat. We'll see that it looks similar, but it's blockier. The blocks are now clearly visible. But the noise is gone completely, so we've got that going for us. We're also losing quite a lot of detail. We can take a look at it in the limit as well. Let's say a 10 by 10 structuring element, which we'd expect to be very blocky. And you can see that it is quite blocky, and that the white noise here has completely taken over the image because it's first, well, dilated in a large area. And then when it's opened again, it doesn't accomplish much. So let's try now with some salt and pepper noise, where Gaussian noise is more grayscale. Salt and pepper noise is either black or white. So let's see what that looks like with a 2 by 2. Okay. And then let's say it's a 20 by 20. So you can see only the largest contiguous areas of white are still visible, and you'll see that it is grayscale. It's not binarily thresholded. You can see how these boxes are all the same grayish kind of color, and some pixels, maybe from this area, seem to have taken over large sections of the picture. It looks like closing at this stage preserves more detail than opening, which is again what we would expect, since white pixels will tend to predominate in the closed image and black pixels will predominate in the opened image because we're dilating first, we're increasing the amount of land first here. Now I'm not sure what's up because this doesn't look like salt and pepper noise, and it should be. This looks like Gaussian noise to me. See how it's gray? Let's go in and fiddle with it a little bit and see what we can get, because I think we can make it a little better. So we'll stop being so ambitious and using a function. We'll just define, and we'll define this as salt, pepper. So what's nice about Matlab is you can make quick changes. There we go. That's more what we expect to see for salt and pepper noise. I don't know why that wasn't working. So have a look here. In this case, we can clearly see that the white pixels are being removed first in the opened image, and the black pixels are being removed first in the closed image. You notice dilating by 2 just gets rid of the white pixels and leaves the black ones, and vice versa in the closed image. So this is working pretty well. It is possible to combine opening and closing to try and get rid of both the black and the white pixels. But that's the general idea. So let's look at the IM noise function, see if there's anything else that's fun. There's this thing called speckle. You can play around with that. Let's see how it works on that. Ah, so this is pretty effective. Well, so far as it goes. It's multiplicative noise, which means that the black areas will stay black. But the fact that it's a low-resolution image does affect us. And we can try making a more interesting structuring element that's rectangular and see how it should smear the image out quite a bit. And we find it does. You can see that it's getting all smeared out. If we make it 3 by 10, it'll smear out in the other direction. Now it's smearing horizontally instead. So there you have it, a brief, simple introduction to performing morphological opening and closing on Matlab images. If you want to learn more about detecting features in images and separating them into regions, consult the other videos in my group. Thank you for listening.